Now, welcome back to the next discussion, which is actually regarding the meteorites as well as the meteors or asteroids or comets, etc., etc., which were actually the building blocks when the Earth was being accreted at about 4.567 billion years ago. Obviously, now you will be having these questions that how are we or how come it we know about the origin and the timeline of those, and from where actually. When the solar system was being formed, the earliest part or counterpart of the solar system was one which is known as protosun. Okay, and some of the planetary bodies, or rather what should we call embryos, were in a motion as per gravity, as well as in a very unstable cataclysmic physical domain, where the smaller bodies or embryos were undergoing different types of collisions, as well as when the collision was on place at par. During this process, suppose this is the region or outer region of a protosun, and there are some smaller bodies or planetesimals or embryos, and they are moving around in their own velocity and motion around this protosun. It is protosun. Now, what was happening was that these smaller embryos will somehow get collided with each other at some point to maintain, or while they were moving towards or away from each other. And during this time, the gaseous materials would have moved outward. However, the more heavier elements would have concentrated themselves towards inside. And during these violent collisions and whenever they were happening, before and after, at around just 1.5 or 2 million years, if the embryo was small enough in size, like it is just like, which is, suppose it has a diameter of 50 kilometers or something smaller than that, there will definitely be some in these embryos. What will happen there? There will be certainly some of the pore or melting of the substances to the center of these embryo. However, if I try to, get a better idea of this, if it is larger, I am taking a larger sized embryo, then the incrustations will be smaller in size, and these incrustations will be accustomed with some superficial or weathering processes by some water vapor or other molecules which are gaseous in nature, as well as whenever the melting will happen inside, some of the materials will sink to the core by the partial melting, and the alloys like iron elements like iron, nickel, they might form alloys with sulfur and other heavy metals. Okay, and they will sink at the bottom and they will create some fragments, or they will be surviving some of the fragments. However, during this melting, some of the gaseous matters will also try to escape this system, and they will create some small fumaroles, and they are again in presence of the sunlight and other weathering in this violent situation. And with time, 1.5 million year, 2 million year, after the 4.567 billion years, then slowly these aggregates will be, will collide with each other, and they will be creating larger planetary bodies. And the thing is that whenever these earlier planetesimal or planetary bodies, these whenever getting or gets disaggregated or disarticulated by some violent collisions, some of the crustal sections of these will fly out, and however the metallic or the central part will retain its own texture or composition, etc., etc. And the earliest remnants of these fragments can be found in form of the meteorites that we see nowadays. Now, meteorites can be, as I have told, that one is iron or metallic in character, and another will be non-metallic, much silicate, much silica richer, with minerals like olivine, pyroxene in them. These typical meteorites have a group which is known as chondrites. The chondrites or chondritic meteorites must contain some chondrule droplets in them. Now, what are the chondrules in the chondrites? Now, chondrules are nothing but, as you can see, that these are actually the formation, or these are related to the formation processes of the preliminary or primary solar nebular hypothesis, and then the planets are being formed in a continued fashion from the proto-sun or protoplanetary, or the suppose key smaller planetary bodies, and then they are colliding with each other to form larger planets or rocky planets inside, and the proto-sun is being evolved towards a more layered structure of a sun, which we see nowadays. The question is, how did we come to know that? Now, from the meteorites, obviously, as I've been telling you that. Now, nowadays we can see asteroids as well as comets as well as meteors. You can try to observe this site, and comets are actually, or what scientists think is, the comets do have some dust or gaseous particle with them, and that's why whenever they move over the head, there is a trail of those gas, and those gas and dust gets illuminated by the sunlight, and that's why we can see their tail. And the asteroid does not contain this type of concentration of those materials, and that's why most of the scientists still they thought that the comets were pretty much different from the asteroids. or some building blocks of the earliest planets. However, recent findings of some scientists have shown that the asteroids might contain some of the volatile matters in it, and so there is a debate regarding their genesis or evolution as well. You can also observe the findings from the comet body Vesta recently by NASA. And meteors are nothing but those parts or fragments of the earliest planetesimals. They were moving around and they have not fallen from the sky yet. The meteorites, on the other hand, have found its way on the Earth, and they have found their way in the deep of the ocean as micrometeorites, as well as they have found their way in the Antarctica. Some of the discoveries nowadays tell that there is a large chunk, or there is a large possibility, or there are some iron meteorites which can be found beneath the ice of the Antarctica. So as according to, I was telling that iron meteorites are mostly look like this, okay, and there is nothing pretty much, and these are very heavy, and this was, as it is seen, it was found from Siberia 1947, and there is a stony meteorite. You can see that there is a individual of the eucritic meteorite from Australia, and you can see that there are smaller fractions in them which can be observed as chondrules, okay. So iron meteorites, in most of the meteorites, iron content is approximately 90 to 95%, with the remainder comprised of nickel and trace elements. And iron meteorites are subdivided into classes both by chemical composition and structure. Iron nickel meteorites, they are practically known as kamacite and teenite. However, the stony meteorites, they do contain these types of chondrules in them, okay, and these chondrules do separate them from iron meteorites, and these are very interesting features where we can see some silicate minerals like olivine and pyroxene. However, the ground mass of these, or the intermediary zone in between these chondrules, are composed of hydrous silicates. As per hydrous silicates, as well as you can also observe some amount of organic matters like ammonia and carbon in them also, like in C2 carbonaceous chondrite. C2 carbonaceous chondrite, and this is one of the interesting reasons why the investigation may be done in some of the carbonaceous chondrites to locate any type of organic molecule or some pre-biological, suppose actually it's a biological or some ammonia like molecule before even the life had started in the solar system, as we know of. Chondrules are teeny grains originated in the solar nebula and therefore predate to the formation of our planet and the rest of the solar system. That is an important issue. Now, if the age of the Earth is like 4.5 billion years, and then if a chondrule is aged around, higher than that, then obviously the chondrules will be much more older than the Earth itself. Stony iron meteorites, they are composed mostly of a mixed nature or character. Stony iron meteorites also can be different, and there are examples like pallasite and etc. etc. Look at the beauty of this. Okay. Now to be much more precise regarding them, as I was telling that this is how a chondrite or chondritic meteorite look like. The grains, as well as you can see that there are some silicate minerals, and silicate minerals, they often have some solutions of iron or nickel in it, and however the ground mass is composed of hydrous silicates. Sometimes these meteorites do have certain amount of alloy in it, or iron nickel alloy in it. And look at this, chondrites contain diverse proportions of the three components refracted inclusions, metallic and matrix material. And the oldest component in the solar system, it is aged around 4.567 billion years. And most of the chondrules, even if they are smaller, sometimes we do find some of the larger chondrules in them also. And as I have told you that iron meteorites probably had formed due to some melting and during the segregation process of a primitive planetary body, where there was a segregation, and because of that segregation and Fe, nickel, as well as small amount of sulfur which is found till date to the core of these smaller planetesimals. Okay, so if the body, or if a planetesimal like this with some incrustation of some chondritic material or some chondritic, and mostly it is formed by iron and nickel alloys, there is a pattern which we can observe in iron meteorites, which is known as Windman STATTEN pattern, and this is generated by the crystallographic preferred orientation of the alloy of iron and nickel in them, and this do indicate a profuse partial melting, which is not the case for chondrites always. Mostly they could be mostly the chondrites are the mantle parts which contains olivine and other silicates separated from the core fraction of pre-existing planetesimals. Okay. Now this is important because whenever you are going to judge any type of scenario before the generation of the Earth in the solar nebula, then you will have to consider these things, as well as there were another discussion like not only the melting of these embryo, as well as the presence or abundance of the aluminum or iron 27 aluminum and some iron isotopes could have added to the heat or the melting in these planetesimals. So this is a very important thing. The next thing that we will be dealing, or we need to deal with, is that we need to find out that if the chondrites or the chondrules do have some unmelted fractions, can they deliver us to determine the past of Earth and as well as the solar system? What is the oldest dated chondrite? Is there any source of water from the chondrites to Earth during their formation, as well as was the late linear theory to generate the water in Earth at around were necessary? Is the giant impact hypothesis valid to generate the moon? These will be the questions of the planetary or the planetary scale if we want to know the planetary science of the Earth. Now obviously the amino acids were reported from the Antarctic carbonaceous chondrites, okay, and we can do, or we certainly do, or some types of isotopic analysis on them. Now isotopes, that mean that they have stable and unstable, isotopes, stable isotope as well as non-stable isotopes, they can be geochemically analyzed through various instruments nowadays, and the isotopic analysis and the isotopes might vary during some fractionation process, which are generally mass dependent. So this is how you are going to analyze the things. Those are till we have to follow.